Here's the deal. I recently restored the mill and lathe I inherited from my grandfather. So I decided a nice starter project would be a pair of collet blocks. But I made a little error when cutting the faces on the mill. The angles aren't quite right. To fix that, I obviously had to restore the surface grinder, and then make a custom mandrel to mount the collet blocks. I started making the mandrel on the lathe, and everything looked like it was going to be fine, until it wasn't. My lathe is cutting a 1.5 thou taper across the length of this part. This isn't a lot, but it's enough to be a problem for this application. To be fair, this isn't all that surprising considering I have yet to properly level and align this lathe. So today, we change that. This is going to be a tedious and time-consuming project, which is the very reason I've put it off until now. I want to make absolutely sure of where I want this machine before I spend hours leveling and aligning it. I need to make some adjustments to the layout of the shop, which brings me to my first side project. Can I get a counter on the screen, please? Alright, let's get started. To the right of the lathe sits the surface plate. This is a fine spot for this, but I end up tripping over these bleeping casters anytime I stand here, so I need to move the lathe to the left a bit. I'm thinking if I turn the mill on a 45, this will give me clearance to scoot everything down. I'll have to find a new spot for the hydraulic press, but this really wasn't the most convenient spot for it anyway. Well, that didn't give me any more clearance to move the yellow cabinet, but now I really like the feel of this new mill position. Really adds to the feng shui of the shop, plus it looks cool. I do still have about 6 inches to scoot the lathe without causing interference with the door, so I guess that's as far as I'm moving it. Relocating the mill gave more room for the workbench, so I can scoot this down and make a new home for the toolbox and hydraulic press. I'll work with this for a bit and see how I like the new configuration. But back to the main topic. The lathe fortunately came with jack bolts for leveling, as well as pads to place under these. But first I need to get them cleaned up. I'll make this quick, I promise. Two side projects down, and I think we can start on the actual project. This lathe has 7 jacking points, 4 under the headstock and 3 under the tailstock end. I won't be removing the rolling frame from under the lathe, but rather just lifting it off of it. I have all 7 in place, but for now I'm only using the 4 innermost bolts. With those screwed in, it's time to start leveling. Similar to the surface grinder project, I'm using a couple construction levels to get a rough adjustment. It's looking like the lathe is leaning backwards and the tailstock end is about a ½ inch low. So I'll crank down on the necessary jack bolts until these levels read dead center. With that close, it's time to bust out the big guns, again. And by that I mean the precision level. When I used this level on the surface grinder, it seemed like it could use a slight adjustment. I'm going to correct that now before I spend hours chasing this bubble around. Checking this is pretty simple. On a fairly level surface, if this is properly adjusted, it should get the same reading after flipping it 180 degrees. I'm about 1/10 high on the left. Flipping it around to check the other direction gives me the same reading. I guess this level was fine after all, but it never hurts to double check. I'm also curious about its resolution. The thinnest shim stock I have is about 1.5 thou, so I'll place this under the level 10 inches from one edge. If the stated resolution is correct, I should see the bubble move to the left about 7.5 lines. About like that. With all my concerns about the level gone, let's move over to the machine. There are a few ways I can set up this level, but I'm choosing to use the flat of the cross slide. My thinking is that deviations in the bedways will sort of average out through the carriage and make the adjustments easier to follow. To start, I'm checking the level in both directions at both ends of the bed. Now's a good time to explain the importance of leveling, and it's not actually about being level at all. It's easy to think of this machine as a rigid body, but when you consider nearly 4,000 pounds of mass being acted upon by gravity, it behaves a bit like a wet noodle. So we have to straighten that out a bit, otherwise our parts will suffer. My approach from here is to make slight adjustments to all 4 jack bolts until I'm perfectly level at all 4 positions. But not surprisingly, this isn't quite possible. I've gotten this to the point that I'm level in both directions on the headstock end. The tailstock end is also level front to back, but indicating that the headstock is high. This is telling me that I've worked a twist out of the bed, but now it has a slight upward bow to it, and this is where the extra jacking bolts come in. You can easily imagine if all the weight is supported here, then the weight of the gearbox will rotate counterclockwise, causing the whole machine to bend upward. So the two leftmost jack bolts help support this. Unfortunately, it's not as simple as just turning these two bolts. Once they come in contact with the ground, they start taking some of the load off of the other jack bolts, throwing off our previous adjustments a bit. After 2 hours of arguing, the bubble and I have settled our debate, and I think I won. Last step here is to tighten all the jack bolt lock nuts so nothing moves. And just to be sure, I'll double check the level once more. That took quite a bit longer than I thought it would, but I'm extremely pleased with the result. There is just one more topic while I'm in this area. The front 10 inches or so of the ways is removable. I was getting a significantly different reading when the carriage was resting on this section. I removed this segment and cleaned up the interfaces hoping it would solve the problem, but it didn't. Long story short, a strategically placed piece of shim stock got me close enough that I'm okay moving on. Leveling and straightening this machine is only part of the equation for getting good parts. The spindle that holds the material is mounted through a gearbox called the headstock. And guess what? It too has an adjustment. We'll be taking cuts along the length of this bar to see if we're cutting a taper. Choosing a large diameter here is important because it reduces the amount of material deflection that would throw off our measurements. I'm also only interested in measuring the far ends of the stock, so we can hog out the middle section to save a little time. With the bar ready to go, we can make our first measurement cut. This will be a light pass, around 5 thou on the diameter, to again keep deflection at a minimum. Without touching the crossfeed, I'll take a second spring pass at both ends to clean up any material left over from deflection. Let's see what we're starting with. Okay, I'm definitely getting a taper. The headstock is bolted to the rest of the gearbox in 4 locations. 2 bolts under the chuck, and 2 behind this cover that aren't so simple to get to. I don't need to move this much, so I'm wondering if I can just adjust the screws without loosening the locking bolts. Let's take a cut and see if that made a difference. Not even a little. I should know better by now than to think it would be that easy. One of the hold down bolts is behind the change gears, so off these come. With those loose, I'll make a slight adjustment to see how far that gets me. And then immediately put these back because I need the power feed. Now I can take another pass. At this point, I could walk you through my lengthy struggle of making blind adjustments and not getting any closer to proper alignment. Instead, I'll skip to the point after I came to my senses and realized I should use a dial indicator to track my adjustments. Doing this lets me actively see how much I'm moving the headstock. So basically, if my diameter difference is 4 thou, I can adjust it until I read 2 thou on the indicator. This isn't exactly correct because the pivot point of the headstock is kind of unknown, but it will get me close. Switching to this method, I was able to get it bang on within a few tries. And I only adjusted the wrong way once. Before I go removing this stock, I want to use it to check the vertical alignment as well. There isn't really a way to adjust this, so my fingers are crossed that the headstock is horizontal. Lo and behold it is, or at least within a few tenths. With the headstock locked in, we can move on to the last piece, the tailstock. This process is similar to the headstock, where I'll be turning a piece of material, measuring the ends, and adjusting accordingly. But I'll be holding one end in the headstock and the other end in the tailstock in a process called turning between centers. That means I'll need to use this dead center, drive plate, and drive dog. Except this drive dog doesn't seem to work for this drive plate. Weird. Now before I go off and make a drive dog, I should at least look around the shop and see if there's something I can use. Well, looky here. This handmade die wrench just might work. It's been a whole 6 minutes since we've had a good side project, so let's get all these things cleaned up. Good as new. There are a few things I need to check before I start making any chips. The tailstock only has 1 degree of adjustment, that being left and right. This means it could potentially be crooked with no way to correct, making my left and right adjustments pointless. So let's check it with the indicator. The horizontal looks perfect, as does the up and down. Well, never mind then. Let's move on. To turn between centers, I need a length of stock with a center drill in each end. Then I can switch the 3-jaw out for the dead center and drive plate. The piece we just drilled is then held between a dead center and a live center mounted in the tailstock. Crashing the tool holder into the drive pin would be catastrophic, so I'll mark my stopping point before I get going. Let's make some cuts. Just like before, I'm cleaning up the outside and hogging out the middle section to save some time. My first measurement pass is about 2 thou depth of cut with an additional spring pass. Measuring both ends, I'm seeing about a 2.6 thou taper. I'm engaging my newly formed brain cells and using the dial indicator right from the start this time. First zeroing the indicator, I can then unlock the tailstock hold-down bolts and make the adjustments to the screws on each side. I'm looking to move about half the taper deviation. Again, this isn't exactly right because of the geometry, but it should get me close. Locking everything back down, I can start the process over with another cut, then just repeat until the taper is gone. After only 6 tries, I'm bang on, and feeling pretty good about this setup. With my perfectly cylindrical test bar still mounted, I'm going to use it to check the height of the tailstock. If my tailstock is high or low, I should see a difference in the dial indicator. Looks like about a half thou. This won't translate to anything meaningful in the cuts, so I'm going to call that good enough. At this point, it occurred to me that I'm about 75% of the way to having a tailstock alignment bar. So before I break down this setup, I'll just do this one last side project. With this bar, now I can align my headstock without having to take any cuts. I just have to mount this between centers and indicate it in, which should be pretty useful. And with that, the lathe leveling and alignment is complete. We leveled the bed, taking the twist and bow out of the ways. We aligned the headstock parallel to those ways. And finally, we adjusted the tailstock to be in line with the headstock. Now I should have no trouble turning cylindrical parts on this machine. Which brings me back to the whole reason we leveled and aligned this lathe in the first place. I need a cylindrical shaft. The one I turned before had a 1.5 thou taper in it, making it no good for my purposes. So let's start over using the other end of this stock. I'm holding this in the chuck and supporting it with a live center in the tailstock we just aligned. After taking a few cleanup passes, I decided to double check that I'm cutting straight. And boy, I'm glad I did. Over this 9-inch cut, I'm seeing about a 4 thou taper. What the frickin' heck, man? Everything is locked down, so the only thing I can think is that the live center isn't actually running true to its mount. But this checks out as well. Out of ideas, I guess I'll just realign the tailstock one last time and finish taking this shaft to diameter. The surface finish from the cutting tool isn't the best, so emery cloth cleans this up nicely. And also lets me dial the diameter in consistent within a tenth. Now we can part this off and move over to the surface grinder. My plan is to use this shaft to hold the collet blocks in the collet indexer. This should let me grind each of the faces at the correct angles. The precision shaft we just made gives me a way to indicate everything in parallel to the travel of the table. Of course, there's a little bit of run out in the collet indexer, so these adjustable parallels support the underside of the shaft, truing everything up nicely. Setting up the first face is a matter of clamping the collet indexer while holding the collet block horizontal. Another adjustable parallel aids in this. As you can see, I have a pretty narrow window to make these cuts in, and I definitely don't want to crash into either the collet indexer or the clamp on the other side. Setting the hard stops for both directions is absolutely critical to preventing this, so I appreciate this feature on the grinder. And that's it for the setup. Let's make some sparks. While this setup is quite fancy, its rigidity is questionable, so I'll be taking this nice and easy with no more than 1 thou passes. After clearing the first face, I'm taking a few more 1 thou passes and zeroing the Z-axis hand wheel. This will ensure I cut each of the faces to the same depth and cover me if one of the faces is lower than the others. With all 6 faces ground, I can tear down this whole setup, clean it, and reset the same way with a square block. I have to say, standing in front of this machine for a few hours repeating the same motion over and over again is quite therapeutic, and the results of those efforts look spectacular. But now the true test. How do these measure up? The goal is that the collet center line ends up parallel to each of the faces, and it would appear that that is not the case. Somehow I managed to make the blocks worse. Awesome. Measuring the faces themselves confirms my suspicions. The locking ring side of the collet blocks is a few thou thicker than the collet side. This holds true for all the faces on all the blocks, which would indicate that there's something consistently wrong with my setup. Reflecting back on it now, I believe I know my problem. The collets only grip for about 1 inch. In my setup, this leaves the locking ring side of the collet block unsupported. I got a bad feeling about this before I started cutting, but decided to just take it easy. I should have trusted my gut. I guess it's back to the drawing board once again. Even though the collet blocks didn't turn out exactly as I hoped, I'm one step closer to having a fully functioning machine shop, which counts as a win in my book. Who knows, maybe one day I'll be able to complete a whole project without needing a single side project, but that's doubtful. Thanks for watching and see you next time.